Okay, the second example I have here shows you kind of that worst case scenario again, and I'm not going to take time to go through it. I'm going to let you, if you want to, go through it and try it out on your own to make sure you understand what you're doing. What basically happens here is we have to convert both equations to standard form. And it's a time-consuming process. So if you do want to go ahead and you want to try this one on your own, I'll tell you that this first plane, the equation comes out to be x plus 2y plus 3z plus 4 equals 0. And the second equation comes out to be x minus y minus 3z minus 8. And then you proceed with the process on the previous example that we just did. So we're at this stage right here, and this is where you would start. I don't want to go through it because it's really repeating number one. So in the end, your final answer for this one, for those that are going to go through and do it and try it on your own, you're going to get x equals t plus 4, y equals negative 2t minus 4, and z equals t as a solution. So rather than going through and wasting your time with that process. So that's what needs to be done. So convert to standard form and then solve. All right, and again, it comes out to be a line. The third example I want to look at then, it shows that check in action. So when you go through and I name this equation 1, this equation 2, that check process helps us avoid the work from the first example, potentially. So normal 1, in this case, is 1, 2, 3. And I don't have to take anything out. It's already with a 1, so it's going to be easy to compare. The second normal is 4, 8, and 12. Take out a scalar value of 4, leaving me with a 1, 2, 3. So therefore, normal 1 is equal to a quarter of normal 2. So the question then becomes, is D1 equal to a quarter of D2? So that's what you're looking at. So we know that D1 is equal to, and D1 is the constant, so that's negative 6. 1/4 of D2 is equal to a quarter of, and it's the negative 25. Well, it's not divisible by 4, so we know then that that statement's not true. So just moving over here, so therefore D1 is not equal to a quarter of D2. So what that tells you, going back to that previous or the first slide, if the normals are equal, a multiple of them, but the constant is not equal, and I'm looking at this one right here, then we know the situation we have is two parallel planes. All right, so we can make that conclusion. So therefore, the planes are parallel. So you never actually have to do any algebra in this case. The only time you have to do algebra is if they actually intersect. Planes are parallel. No solution. All right. So then all that's left now is to try that homework on your own. Where it went on me. Oh, way down at the bottom of this slide. So there's the homework. Make sure you do a couple that you can, again, the process is different than a line and a plane. So you need to be able to differentiate the difference when you get to a test situation when you don't have the notes in front of you. So please keep that in mind.